Hello, my name is Brian Devine. I'm one of the mathematics instructors here at Hamilton Education. Today we're going to look at the answers for our ACT Practice Test 105. So let's begin. Question number 1. The morning PE class of 18 students decided to play a game of soccer by forming 2 teams. From the class of 18 students, Julian and Michael were selected to be the team captains. They flipped a coin to see who would go first in selecting the team. What's the probability that Saul, one of the 18 students in the class, is picked first? Well, if we started out with 18 students and Julian and Michael were selected to be captains, that leaves us with 16 people from which to choose. And Saul would be one of those 16. So 1 out of the 16 left to choose from would be Saul's probability. C. Number 2, which of the following statements must be true about the figure below? Well, if we look at these 2 triangles, there's a few things that we can see. I can see that this side is the same length or congruent to that side, and that this side is the same length or congruent to this side. And we can see that the angle between them in both triangles, the congruent sides respectively, is also, the angles are congruent. And so these are congruent triangles. Now, looking at the way that they're congruent, I can see that A, B, C would be congruent to the triangle named Q, which corresponds to A, R, which corresponds to B, P, which corresponds to C. So I know a couple things right away. I know that angle A and angle Q are the same measure, and B and R angles are the same measure, and C and P are the same measure. And I know that AB is congruent to QR, and I know that BC is congruent to RP, and I also know that AC would be congruent to QP. And I want to know what must be true. Now that I've gone through all that, well, is A congruent to P? No, that's not true. Is B congruent to Q? No, they don't match up. A and Q match up. Is C congruent to R? No, C is congruent to P. AC, is that congruent? Well, yeah, that's true. That's one of the things that we established. And so the only thing that must be true would be J. And we can see right away that BC should match up with RP, and this isn't RP, so K wasn't true. So J is our answer. For problem number 3, another geometry problem, we're told that A, B, and X, Y intersect at the point P, and that AY is parallel, so AY here and XB there, they're parallel, which means that this angle and this angle must be the same. So I know that this is 20 degrees. And I know that this angle and this angle must be the same. So this is 40 degrees. Now, how do I know that? Because parallel lines cut by a transversal alternate interior angles. Now, using the triangle sum theorem, I know that in triangle XPB, the sum of the 3 angles inside's got to be 180. And so this other interior angle here must be 120 degrees, because 120 plus 20 plus 40 is 180. And these 2 angles here, T and XPB, must add to 180. And so that tells us right away that T must be 60 degrees, which is C. In number 4, Mrs. Baker surprised her first grade class with a sundae bar, and They got 3 toppings to choose from. They could get peanuts, they could get sprinkles, they could get chocolate chips, they could get any 2, they could get all 3, it looks like. And Miss Baker tracked what her students chose in the Venn diagram below. So one group of students, 6 students, chose the same toppings for their ice cream. And I look down and I see, well, just sprinkles, just peanuts, chocolate chip peanuts, peanuts, sprinkles, or all 3. Well, all 3 would be the intersection of all 3. And that's not a 6. In fact, I do see a 6 right here. And 6 would be an intersection of peanuts and chocolate chips. And heck, that is an answer. So H. H represents 6 people, or first graders, choosing chocolate chips and peanuts only. For problem number 5, we're given an algebraic string, there's parentheses, there's absolute value bars, and I remember PEMDAS. Parentheses, then exponents, then multiplication and division, followed by addition and subtraction as I move left to right through a string of operations. So this order of operations, I'm going to take care of parentheses first. So this would be equal to 2 times -3. 10 minus 13 is -3. Minus 9 times, and I treat the absolute value bars as parentheses. And I see that this would be the absolute value of -3, which would be +3. So minus 9 times +3. And I can see -6 minus 20, pardon me, 81 would be -87. A would be your correct answer. For number 6, the portions of the graphs of x minus 2 squared minus 2 and -2x plus 1 are shown below, although a portion of each function is shown. And we want to know if it can be determined at what xy point do they intercept. Well, let's draw this line. Let's see if I can get this thing to fit on there. If that'll move over. We need to go over there. Yeah, it's sort of like it. What do you think? Pretty close. See if I can get it to pivot just a little bit. Now, if I look at that, it looks like it's intersecting. Well, if I drop down from this x value, it looks like there's the y value. Well, -1, -1, 2, -2, it's not doing both of those. I mean, I can see a point of intersection. I can visualize a point of intersection. So now I'm going to go to the equations and see if I can, well, f of x and g of x has to be the same at the same x. So x minus 2 squared would be x squared minus 4x plus 4 minus 2 would be plus 2. And that has to equal -2x plus 1. So if I were to add 2x to both sides, I'm going to get minus 2x. And then subtract 1, I'm going to get 1 equals 0. And right away I see that that's a perfect square trinomial. That's x minus 1 squared equals 0. So this must be 1, -1, and the answer is F. For number 7, Adrian built a model of a jumbo jet just this last weekend. And the model was designed on a scale of 1/2 inch on the model represents 6 feet on the jumbo jet. Actual jumbo jet. So I want to know, hey, then the wingspan of the model is 21 inches. How long is the wingspan of the real size jumbo jet? So if we're told to scale, then we can use the idea of a proportion, because I know that 6 feet to 1/2 inch has to equal the real number of feet to 21 inches. And with a little magic algebra mumbo jumbo, I can cross multiply. Actually, I just need to multiply by 21. And I'm going to get 2 times 6 times 42, or pardon me, 21. Did them in my head ahead of time, is whatever question mark is. So what's that going to be? 6 times 42 is 252. So the real jumbo jet has got a 252-foot wingspan, E. For number 8, the cost of renting a limousine for a Friday night is $100 for the first 10 miles. So I got to pay $100 for the first 10 miles, and then $5 for each additional mile. And I want to know what's the cost of a 25-mile ride. Well, I've got to pay $100 for the first 10 miles. And then I take 10 away from 25. I got 15 miles left that I have to pay $5 per mile. So $175, and I'll be riding in style for 25 miles. H is our answer. For number 9, each year, Jeff is given a performance bonus between 0 and 15% of his base before taxes salary. Based on his annual employee review, he was awarded a bonus of $7,800. And this represented 80%, 7,800 was 80% of his maximum potential bonus. Well, the maximum would have been 15% of his base salary. And so if I look at 15% of his base salary, and he got 80% of that, that comes out to be 12%. So he really got 12% of his base salary over adjusted, basically that 80 of 15 became 12%. And so what we can do is take his bonus and divide it by 12%, because 12% of his actual salary was his bonus. So if we divide both sides of that by 12%, we're going to get his actual salary, base salary, which is $65,000. And what I just found out there is Jeff's making far more money than I am. B. For number 10, Frankie was in charge of dinner tonight. This is what we're going to have for dinner, so everybody, here's the menu. He's decided to serve 2 vegetable dishes, and in his pantry he had several cans of vegetables. The type of vegetable, the quantity for each is listed below. Frankie randomly chooses the first can in the pantry. We want to know what's the probability that the can he selects does not contain corn. And so if I look in there, what do I got? I've got 20 cans. And the ones that don't contain corn would be just peas, just green beans, because the mixed has corn in it. And so I'm going to have 6 out of the 20 cans don't have corn, which would mean 3/10 of the cans, or 30%, don't have corn. So G is the correct answer. For number 11, Greg replaced an old garden bed with a larger new one. The new garden bed requires 4 cubic feet of soil. And he's planning on taking 2 of the needed cubic feet from his old garden bed. So he's going to need 2 more cubic feet. And the bags come in 3/4 cubic feet, and he can't split bags. And so we want to know, how many bags does he need to purchase in order to achieve his goal of 4 cubic feet. So if I take the number needed, which is 2 cubic feet, and I divide that, what's in each bag that I can purchase or that Greg can purchase, then I'm going to end up with 8/3. When I can turn a division by a fraction into a multiplication, so 2 times 4/3 is 8/3. And now, note, that's going to be 2 2/3. And Greg, pardon me, I keep saying me because I was actually gardening the other day and upped my volume of soil by not as much, but just a little bit. But he's going to need to get 3 full bags. And so B would be the correct answer. For number 12, what is the slope of the line passing through point X that's perpendicular to AB? Well, what's the slope of AB? I got 2 points, so the slope of AB, we'll call it that, has to be 2 minus 1 over 2 minus 0, change in y over change in x, which is 1/2. And I know that the slope perpendicular is the opposite reciprocal. So I flip that fraction over and I negate it. And the slope of that line would be -2. Question 13. One factor of the polynomial 21a squared minus 12a minus 9 is 3a minus 3. Which of the following is the other factor? Well, I'm looking at this thing here, and I see that I can take a 3 from both terms. So I can factor that as this, which means that I could have pulled a 3 out of here, rewritten this as 3 times, 7a squared minus 4a minus 3. So a minus 1 must be a factor of 7a squared minus 4a minus 3. And I can go about this in several ways. The easiest way would just be to do a quick synthetic division. I could go 7, -4, -3, and this would mean I'm putting 1 as my multiplier, whatever makes that 0. I drop the 7. 1 times 7 is 7. Add together, I get -3. Pardon me. And 1 times, +3. Golly. And 1 times +3 is 3, and I can see that my remainder is 0, so that implies that I could have written this thing as 3 times a minus 1 times 7a plus 3. And I can see that C then is the correct answer. For number 14, given that tangent squared of x equals 4, then the tangent of x must be plus or minus 2. I just take the square root of both sides. Now, whenever I get something like this, the easiest way to see the answer is to draw a reference triangle. For this to happen, well, if I look on a coordinate plane, I'm either going to have a triangle in quadrant 1 that has a tangent of this angle is 2, or I'll have a triangle over here in quadrant 2 where this is -1 and this is 2. So the tangent of this angle would have the same tangent as this angle, which could be x. Now from that, I can see right away that the hypotenuse length must be the square root of 5 on both of these triangles. And so secant of x must equal plus or minus root 5 in this case, hypotenuse over adjacent, which means that secant squared x equals 5. And J is my answer. Now, I could have used tan inverse here. X would have been tan inverse of plus or minus 2. I could have looked at either one of those. Found x, I would have just been looking at this triangle here in the first quadrant. I could have found x and then applied trigonometry to that. 1 over the cosine of that square. Several ways I could have done this, but I always like the reference triangle because it's simple, it's quick, and it emphasizes SOHCAHTOA trigonometry. For question 15, in the figure below, all of the small squares are equal in area, and the rectangle PQRS is 1 square unit. Which of the following expressions represents the area of the shaded region in square units? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 8 tenths. And if I look at it from left to right, I see 1, 2, 3, 4, 5, 6. So this length here is 5/6. And so if I look at that together, well, this area then would be 5/6 times 8 tenths. 5 times 8 is 40. And 6 times 10 is 60. Or better yet, I had the answer right in front of me the whole time, which meant you did too, D. In problem 16, in this triangle below, PQR, the measure of angle R is given as 35 degrees. And I'm told that PR, this one, and PQ are congruent, i.e. the lengths are the same. Well, it means that this is isosceles, so this base angle is 35 degrees. And this angle here must be 180 minus 35 plus 35, which would be 110 degrees. And so this used the fact that the sum of the three angles in a triangle are 180. And in an isosceles triangle, if we know one base angle, we know the other, and thus can find the vertex angle, 110. For number 17, the first 5 terms of a sequence are shown in this table. And the sequence is defined by setting the very first number in the sequence, the first term, is 2. And then the next term is 3. And then every term after that depends on the 2 terms before. So we can see right away that when n is 3, 3 minus 1 is 2, and 2 times the previous term minus 1 times the 2 terms before that should give us the next term. And this repeats over and over again. So we're asked to find the 6th term of the sequence. Well, then the sixth term should equal 6 minus 1, which is 5, times the term before, which is 12, minus 6 minus 2, which is 4, times 2 terms before, which is 6. So this would be x to the 6 minus 1. This would be x sub 6 minus 2. And n is 6. So I just plug those values in to the given formula. And I find, well, what's that come out to be? That's going to be 60 minus 24 equals 36. So 36, E. For number 18, in the standard XY coordinate plane, the line represented by which of the following equations goes through 3, 0 and is perpendicular to the line y equals 3x minus 6? Well, this line has a slope of 3. We can see it. It's in MXB form. So the slope perpendicular, as we talked about a few problems back, would be the opposite reciprocal. So we want a slope of negative 1/3. And it goes through 3, 0. So we can use the point slope form of a line. Y equals mx minus the x value of the given point plus the y value of the given point. So we do that. Y equals negative 1/3 x minus 3 plus 0. And we get y equals negative 1/3 x, which points us at F and G, plus 1, which points us at G, as the correct answer. For number 19, Zoe's replacing the tile flooring in her 8 by 10 foot rectangular kitchen. So she's got 80 total square feet in this kitchen. There's a 4 by 4 foot island in the kitchen that doesn't require flooring. So we're going to end up not covering 16 4 by 4 square feet. Now, this leaves Zoe with 64 square feet to be covered. And each one comes in a box of 8, and each tile measures 1 by 1. So if I divide this by 8, then this tells me that she's going to need 8 boxes. Because there's 8 square feet per box. And C is the correct answer. Question 20. A cable company conducts an automated customer survey immediately following a customer call into their service center. The results from a typical weekday are summarized below. We have what's called a bivariate table, where the rows ask the question, was this the first time calling about the issue? Answer yes or no. The columns ask the question, was your issue fully resolved? You can answer no or yes. The question prompt says, assuming the same customer satisfaction trends hold, and the call center is anticipating 300 surveys for a day following a holiday, what is the expected number of customers that called for the first time and had their issue fully resolved? Well, I can see right here that 75 people had their issue resolved that had called for the first time. So people that answered yes to both the questions. Now, this is 3/4 of all of the people that are here, because this adds up to 100, about 102. So what we want then is 3/4 of 300 would equal 225 people. So H is your correct answer. Question 21. In the standard XY coordinate plane, the graph of the line AX plus 2Y equals 7 passes through the point -3, -4. What is the value of A? Well, they gave us an X and a Y that's on this line, so let's plug them in for X and Y. So -3 times A plus -4 times 2 has to equal 7, according to what they gave us. So -3A has to equal 15, adding 8 to both sides. So this tells us that A must be -5. And A is your answer. For number 22, given P and Q such that x to the 3p equals x squared, well, that means 3p must equal 2. And x to the 4q equals x squared, well, then 4q must equal 2. For all positive x, what is x to the p over x to the q? Well, we just found out that p is 2/3 and q is 1/2. So we must have then that x to the p over x to the q, which by the quotient rule is x to the p minus q, must equal x to the 2/3 minus 1/2. And I know that x to the 2/3 is 4/6 and 1/2 is 3/6, so this is x to the 1/6, which we could write as a radical as the 6th root of x, which is f. For number 23, the transformation t takes a point xy and takes it to 4 minus y to x minus 1. Find the image of the point -1, 2. Well, that must go to 4 minus y, which would be 4 minus -2, and 2 times -1 minus 1. Or 6 -3, which is E. For question number 24, given that t equals x over 2y plus 3, which of the following expressions is equivalent to y? Well, we could use algebra and rewrite this as 2y plus 3 equals x over t. I can multiply both sides by 2y plus 3 over t. And I can take 3 away and divide both sides by 2. So y is going to be x over t minus 3 all over 2, which I can clean up as x over 2t. minus 3/2. And G is our answer. For number 25, Adam has a ribbon measuring 16 pi centimeters. And that can be wrapped twice around a circular tin. Well, that tells us that the circumference of the can is half of that. If it goes around twice, the circumference of the can must be 8 pi. And I know that this equals 2 pi r. Well, this tells me if I divide both sides by 2 pi, that the radius of this can must be 4. So A is the correct answer. For number 26, a circle with a radius of 6 is shown. And the measure of angle OAB indicated is 75 degrees. And I want to know what is that angle measure in radians. Well, recall that if I'm going from degrees to radians, I multiply the degree measure by pi over 180 because the idea of a unit circle if the radius is 1, the circumference is 2 pi. So in 360 degrees, I went 2 pi radians. So we take 75 pi over 180, and we get 5 pi over 12. Which is F. For number 27, a circle has an area of 32 pi. So remember the idea of area as pi r squared. Well, then the radius squared must be 32, which means that the radius must be the square root of 32, which is 4 root 2. And the circumference is 2 pi r, so 8 pi root 2 b. For number 28, given that A is -2, B is -0.1 or -1/10, which of the following produces the smallest result? Well, if I took A minus B, I'm going to get -1.9. If I took A divided by B, I'd get 20. If I took A times B, I'd get positive 0.2. B minus A would be positive 1.9. B divided by A would be positive 0.5. The farthest left on the number line would be the least, so F is the farthest left. It's the most negative value. It's the only negative value there. For number 29, Janice was recording the temperatures for one day last winter as part of a homework assignment. She recorded the temperature reading from 3 a.m. to 3 p.m. over 12 hours and in degrees Celsius. What was the range in temperatures in degrees Fahrenheit? And we're given a conversion here. In fact, this conversion, we can convert it. This tells me that Fahrenheit would equal 9/5 Celsius plus 32. Now, our range, we can see, is between 10 and 20 degrees Celsius. So in Fahrenheit, this would be 9/5 of 20, which is 36, plus 32, which is 68 degrees. And 10 degrees would be 9/5 of 10 plus 32, which is going to be 32 plus 18, 50 degrees. So I can see right away the range would be 18 degrees Fahrenheit, 68 minus 50. And the answer is C. For number 30, a total of 10 juniors and 15 seniors were participating in a 10-kilometer event. The top 3 finishers in each grade level will earn a gold, silver, and bronze. Which of the following expressions gives the total number of different finishes that could happen from the 25 athletes competing in the event? Well, if each grade level is going to get its ordered finishes, then this smacks of permutation. In fact, I know that I'm going to have first, second, third for juniors, and I'm going to have first, second, third for seniors. And so I'll have 10 possibilities for first, and then 1 came in, there's 9 possibilities, and then 1 came in, there's 8. So I would have 10 times 9 times 8 possibilities for medals for juniors, and then 15 times 14 times 13 for seniors. Now, it just so happens that this is 10 permuted by 3. And this number here is 15 permuted by 3. And so all possible would be, well, there's all the possible ways that I could have seniors finish. And for all those possible ways, there's all the possible ways that I could have juniors finish. And so this becomes a permutation and fundamental counting principle idea, and our answer is K. For number 31, which of the following expressions would be equivalent to root 2 over root 5 minus root 2? Well, this becomes a rationalize the denominator idea. And in order to do that with this thing, what I have to do is I have to force a difference of 2 squares in the denominator. So what I'm going to do is I'm going to build a funky version of 1 out of the conjugate of the radical term on the bottom of the original. Now, this is really just 1 that I'm multiplying by, but it's going to change the look. Multiplying something by 1 doesn't change the value, but it will change the look of this. Because on the top then, I'm going to have, well, I'll end up with root 2 times root 5 is root 10. And then root 2 times root 2 is going to be 2. And on the bottom, I'll get the square of the first term minus the square of the second term, because I forced it to be a difference of 2 squares. And so this will be 2 plus root 10, writing it in the order of the problem answers, over 3. And I can see right away that C is the correct answer. Now, some of you might have calculators that will do this. Explore that possibility. I'm going to show you the mathematics of it, but it's possible that your calculator may have helped you there as well. In problem 32, we're given a diagram of an aircraft carrier and we're shown two right triangles. And so I know that this aircraft carrier is so big and it weighs so much, and the aircraft carrier can support a crew, and okay, cool. When written in scientific notation, which of the following expressions is equal to the water displaced? Well, it displaces this much water, we're told in the prompt. And in scientific notation, I would write that as 1.02, and then I moved 1, 2, 3, 4, 5, so 10 to the fifth. So I should have that as one of my answers, and behold, J. For number 33, the distance from point A to B and point B to C is 820 and 140. So A to B is 820, and this is 140. So I know that this is 140. This is a right triangle, and this is 820. Which of the following values is closest to the length from A to C? Well, you're going to have to probably get out a calculator for this one, but this should then be the square root of 140 squared plus 820 squared. Which comes out to be approximately 830 feet. That's definitely a calculator problem. I'm not that good. For number 34, if D to E has a length of 730, so we know this is 730, and the angle measure E is 15 degrees, so I know this is 15 degrees. And I then want to know, how can I find the distance from D to F? Well, if I look at that triangle, see if I can draw this. It's not as pretty. But this is 730, and this is 15, and I want to find the height there from D to F. Then I should have the idea that tan 15 is equal to question mark over 730, opposite over adjacent, TOA. Multiplying both sides by 730 takes me right to, pardon me, right to F. For number 35, a triangle has side lengths of A, B, and C, where the side A is twice as long as the side B. Which of the following gives all values of C? So I could have something like this. I could have, let's make that C, and then this A, undo that one. I'll make that twice as long. We'll do it something like this. C, B, A. Or I could have something like that. Well, what do I know right away? I know that A is twice as long as B. And the fact is that in any triangle, that given two sides, then the third side must be between the sum of the given two sides and the difference. So C then must be between A plus B, which would be 2B plus B, and it must be greater than 2B minus B, which would just be B. And so by the idea here is that C has to be between the sum of A and B and the difference of A and B. Has to be. Otherwise, you couldn't form a triangle. And so that points us directly at C. Subbing in 2B for A puts us right on C. For number 36, Miguel just bought a new rectangular fish tank. That's a foot wide, so 12 inches. 1.5 feet deep, so that's 18 inches. And he's going to fill it to 10 inches, 2 inches less than a foot deep. So the volume in cubic inches would be that times that times that. Length times width times height of the water, which is 2160 cubic inches. So if I take that, 2160, divide it by how many cubic inches are in a gallon, 231. This should give me how many gallons I'm going to need to fill, or Miguel's going to need to fill his aquarium. And it comes out to about 9.4 on a calculator. So H. So Nacho is selling corn in a cup to raise money for his end of year camping trip. And he estimates that each 8-ounce cup, let's highlight some of this, is going to cost 40 cents. And that includes the cup, the corn, and condiments. So he had to buy a new crock pot that cost him $35. So his costs are going to be 40 cents per cup plus his crock pot, $35. And he's going to charge $1.25 for each cup. And we want to know which of the expressions would represent the number of cups he needs to sell to profit $50. So remember that profit would equal revenue minus cost. And so what he wants is his revenue, which would be $1.25 per cup, minus his cost, which would be 40 cents a cup, plus $35, to exceed $50. So we just took the words and translated them into something that we could deal with. So if I take 1.25 minus 0.4, that's 0.85 C minus $35 has to exceed 50. And we can see right away that is D. For number 38, John and Fred have a total of $80. Fred and Lucas have $110. John and Alex together have $105. And I want to know, how much do Alex and Lucas have? Well, let's say J is John and F is Fred. And we know they got $80. And I know that Fred and Lucas have 110 bucks. And I know that John and Alex have 105 bucks. And if I take all of this and add it together, I know that John twice plus Fred twice plus Lucas plus Alex have a total of $295. And so if I take these guys away, then that's taking twice this away. Well, let's do that. So if I take away 160, then, whoops, we must have Lucas and Alex have $135. So H. For number 39, you're given a floor plan. We were described one earlier when someone was trying to put flooring in. And this tiles, and this figure below represents the top view of a warehouse used for gymnastics. The warehouse is in a rectangular building, 150 feet long, and it looks like it's 60 plus 60, 120 feet. Yes, it is. There's a rectangular viewing area that's 60 by 120, pardon me, 60 by 20. And in the far corner, there is a 50 by 70 foam pit filled with small cubes of foam. With the exception of the foam pit, viewing area, the rest of the flooring is covered by 6-inch foam to absorb though jumping and falling. 39. The 6-inch foam flooring needs to be replaced every 2 years. How many square feet of foam flooring are needed to cover the entire warehouse, excluding the foam pit and viewing area? Well, I'm going to have 150 times 120 would be the actual floor space of the warehouse without the pit. And then I'm going to have to take out the pit, which would be 70 times 50, and the viewing area, which would be 60 times 20. And I do that. And I get 13300, which is D. There's 13,300 square feet of foam that must be laid. Number 40. What percent of the warehouse is not covered by the 6-inch foam flooring? Well, we already figured out that it would be this area here, which is 350, or pardon me, 3,500 plus 1,200, which is 4,700. So 4,700 of the entire floor, 150 times 120, would be 18,000. And that comes out on a calculator to be 0.261-ish. So about 26%, which is G. The foam pit itself is 24 inches deep and is filled up to 16 inches with small cubes of foam. New guidelines suggest that the minimum depth be 20 inches. Well, what do we got to do? So by what factor will the new volume exceed the old? So I would have 70 times 50 times 20 would be the new volume, and I divide that by the old volume. 70 times 50 times 16. And we can see right away it would just be the ratio 20 to 16, which is going to be 5/4, which is a decimal is 1 1/4. B. For 42, a Ferris wheel with a 30-foot diameter reaches a height of 31 feet, and its lowest point is 1 foot off the ground. It takes the Ferris wheel 30 seconds to complete one full rotation. Starting from a reference point at the minimum, at time 0, the height of the point on the Ferris wheel can be modeled by a function, h of t equals 16 minus 15 cosine 2 pi over 30 times t. What is the period of the function in seconds? Well, remember from trigonometric analysis, the idea is that if we're given a transformation of cosine, so if I take cosine of some angle and I multiply it on the outside, or I add or subtract something on the outside, that's going to change the vertical. Whereas if I multiply on the inside, or add or subtract on the inside, it's going to change the horizontal. And this number here in particular affects the period. If we take the old period of cosine, 2 pi, divide it by the b number here, 2 pi over 30, we get the new period. So this will give us the period of this Ferris wheel, which we can see is 30 seconds. Now, I will point out they told us the answer in the problem. Okay, for number 43, given that I squared equals -1 and that p is some positive integer, what is the value of I to the exponent 12p plus 7? Well, note that we could rewrite this as I to the 12p times I to the 7th by exponent rules. And this then would be I to the 12th to the p times I to the 7th. Now, I to the 7th, let's figure that out first, and then we can figure the other one out. Well, I to the 7th, note that I to the 1st is equal to I, and that I squared equals -1. We were told that. So I cubed equals -I. We can multiply -1 by I. And I to the 4th then would equal +1. And we multiply that by I, we're going to get I again. So I to the 5th would be I, and I to the 6th would be -1, and I to the 7th would be -I, and I to the 8th would be 1, and we could repeat this over and over again. The main thing is that we know what I to the 7th is right away. It's going to be -I. We also know that every 4 times we do this process, that I to the 12th, I to the 16th, any exponent that can be multiplied by 4 would equal 1. So this equals 1, I to the 12th. And the whole thing would be 1 times -I. So we have -I as our result. For number 44, Lucy recorded the number of hours of homework for each day during the first 28 days of the school year. Her data is recorded in the bar chart below. Which interval contains the median number of hours of homework she had per day during the first 28 days of the new school year? Well, the median would be in the middle. And if we look at this, what this says is that, well, she had 7 days that she studied for about an hour, and she had 8 days that she was within 1 and 2 hours, and she had 6 days she studied for 2 or 3 hours, and she had 4 days where she studied 3 or 4 hours, and she had 3 days where she just turned it on. And if we look at that, well, the median number should be in the middle. And out of 28 days, it should be the 14th and 15th from either end. And if we count 14 to 15 this way, we're going to end up in stack 1 to 2 hours. And if we count 14 to 15 hours this way, we're going to end up in stack 1 to 2 hours. So the middle value would be G. Now you could also write this. You could write this out 7 times, then this 8 times, then this 6 times, and then this 4 times, and then this 3 times, and count from either end into the middle. And you're still going to end up in this area here. So G was your friend there. For number 45, for all real numbers x, y, and z, where xz equals 2 times x plus z, which of the following expressions is equivalent to x plus y over x plus y plus z over z? Now this is really just an algebra game, and I'll show you what I mean here. First thing I'm going to do is I'm going to get a common denominator here. And note my common denominator is going to be xz. So I could have rewritten this thing as z times x plus y plus x times y plus z all over xz. So if I clean that up, I'm going to get xz plus yz plus xy plus xz all over xz. And now I'm going to go ahead and sub in 2x plus z for all the xz's. And I'm going to end up getting, well, this one here, in fact, let me highlight them. This one here will become 2x plus z. This will become 2x plus z. This will become 2x plus z. So I'm going to end up with 2x plus z's on top. So 4x plus z plus yz plus xy over x, over 2x plus z. So I did all my substitutions, and then I note this. Hey, I can factor y from both terms here. And I'm going to end up with 4 times x plus z plus y times x plus z over 2 plus x plus z. Now, every term in the numerator has an x plus z, and there's an x plus z in the denominator term, so I can factor x plus z from both top and bottom, and I can see that this conforms to B, because I could rewrite this as y plus 4 over 2. So it was an algebra game, as I said, from the moment we started the problem. In number 46, we're given that the function f of x is defined as x squared minus 1 over x plus 2. And I want to know then, hey, which of the following is equivalent to this? Well, if f of x equals that, then I'm going to take 1 minus t and plug it in for x in f of x. So I'm going to get 1 minus t squared minus 1 over 1 minus t plus 2. And if I clean that up, I'm going to get 1 minus 2t plus t squared minus 1 over 3 minus t. And if I clean that up, I'm going to get t squared minus 2t over 3 minus t. Oh, I see that. That's G. Number 47. A pizza with a diameter of 12 inches is cut into 8 identical slices. What is the perimeter of one of those slices? Well, let's put a pizza on the board. There's a pizza. And if I cut that into 8 slices, whoops, there we go. So this is 1/8 right here. In fact, we'll put some pepperoni on there. Just to make it look like a piece of pizza. Now, I do know that if the diameter is 12, then the radius is going to be 6. And if the diameter is 12, then the circumference is going to equal 12 pi. And so this must be 1/8 of 12 pi. So if I look at it that way, I'm going to have 6 plus 6 plus 3 pi over 2. So 12 plus 3 pi over 2 is E. Number 48. Consider all positive integers that are multiples of 4 and are less than or equal to 80. What proportion of those integers are divisible by 12? So what they told me is that it's got to be divisible by 3 and 4 to be divisible by 12. And if I look at all of those numbers, well, I know that I'm going to have 12 and 24 and 36 and 48 and 60 and 72. And that's 6 numbers right there. And then if I look at all of the multiples of 4, 4, 8, 12, all the way up to 72, 76, 80. Well, that's going to be 20 numbers right there. So I should have 6 out of 20 or 3 out of 10 H. In number 49, I'm given a kite. And I know that AB and DB, or pardon me, AC and DB are perpendicular. And I do know that DO is 3 and OB is 3. And that OC is twice as long as OA. So if I called this X, this must be 2X. What else did they tell me? The area of triangle ABO is 6, which means that this area must be 6. Now, I do know something right away, is that both these triangles share the same base. And the height of triangle DBC is twice the height of triangle ABD. Well, what does that tell me is that this must be twice the area of AOB, and that must be twice that area. So now I know something right away, that the area of the kite must be 12 plus 12 plus 6 plus 6, which is 36. Now I could have used 1/2 of the base of AOB times the height is equal to 6. I would have found that X is going to be 4. So then 2X would be 8, which right away tells me that triangle COB would have area of 12 and boom, boom, boom. But once you saw that the heights of those two triangles were double, then the areas must have been double. For number 50, the fraction 7/13 can be expressed as a repeating decimal. And I want to know, what is the digit of the 501st decimal place of 7/13? Well, I note this, that this is a sequence of 6 numbers that repeats over and over again. It's called a cyclic sequence. So 5, 3, 8, 4, 6, 1 repeats over and over again. 6 numbers. So if I go out to the 501st decimal, well, what's 501 divided by 6? I should have this idea then, that I'm going to get this equals 83 with a remainder of 3, which means that I would go out then 83 times with this repeating sequence, 5, 3, 8, 4, 6, 1, 83 times, and then I'd go 1, 2, 3 more. And so this should be the 501st decimal. Should be an 8. It's okay, is my, or our, correct answer. For number 51, we're given a triangle, and we're told that it's made up of the lines x equals 0, which is the y-axis, y equals 0, which is the x-axis, and this mystery line mx plus 6. And the triangle has an area of 36 square units, and find the value of m. Well, this tells me it's 6 right here. That would be the y-intercept. And so I know that this length right here is 6, which is the height. And I know that 1/2 base times height, so base would be this length here. So 1/2 base times the height, which is 6, means that 3b equals 36. So b must be 12, which means that the slope must be -6 over 12. Which equals -1/2, which is C. In number 52, the graph of the function 2x minus 5 times x plus 2 over x minus 3 is shown in the standard xy coordinate frame. And I want to know what's the equation of the slant asymptote. The slant asymptote would be this line here that basically defines where this function is going as you go to negative or positive infinity. Well, what I can do is I can just perform this division right here. Is I can literally make that division. So if I look at the top, this would be 2x squared minus 5x plus 4x, so minus x minus 10. And I'm going to divide that then by x minus 3. Now, I can do a polynomial division. I can do a synthetic division. I prefer synthetic because it's quick and easy. Or if you have a good calculator, it will do it for you. Pardon me. But I'm going to take 3, which would make x minus 3 0, and synthetically divide. So I drop my 2. 3 times 2 is 6. And 3 times 5 is 15. And I toss out my remainder, and my line then becomes 2x plus 5. And I could have seen that by sketching, because there is an intercept that would have thrown out f and g and k, and it could only be h or j, and the line had, we saw a slope of 2, so j is our answer. For number 53, the license plates for a country in Europe are made up of 7 unique alphanumeric characters. The first 3 positions are reserved for any of the 26 letters of the alphabet, and the next 4 positions are numbers 0 through 9. And we want to know how many additional license plates can be made if they are allowed to repeat. Well, if they don't repeat, I'm going to have 26 times 25 times 24 possible for letters, which would be a permutive idea. And then I have 10 times 9 times 8 times 7 possibilities for numbers. So this is no repeat. And then repeat, I'm going to have 26 times 26 times 26 possible. Then 10 are possible, 10 are possible, 10 are possible, 10 are possible. And so if I take that, I'm going to take repeats minus no repeats. And I'm going to get 26 cubed times 10 to the fourth minus 26 factorial over 23 factorial times 10 factorial over 6 factorial. So A would have been the correct choice. For number 54, which of the following expressions represents all values in the domain of this function? Well, note that this is saying 1 over, notationally I should say, the square root of x squared plus x minus 6. So what we want is this thing here has to be greater than or equal to 0. So we set that greater than or equal to 0. Pardon me, greater than 0, because we can't have a 0 down below. Now note that I can factor this, x plus 3, x minus 2. Greater than 0. And if I look at that, I know that, well, that's going to be a quadratic that goes through negative 3 and 2 and opens up. And so it's going to be greater than 0 whenever I'm less than negative 3 or greater than 2. So I want x to be less than negative 3 and greater than 2. So K would be the best choice because I can't be equal to negative 3 nor 2. For number 55, a matrix is invertible if and only if it has a non-zero determinant. We're given 4, 5, 2 by 2 matrices. Remember the determinant of a 2 by 2. Say A, B, C, D, is found by the down diagonal product, AD, minus the up diagonal product, BC. So we want to know which of these would have a 0 determinant. Well, this one would be 4 minus 5. Or pardon me, 4 minus 6. That's not equal to 0. And similarly, this one would be 0 minus 1, which is not equal to 0. And if we go down, we get negative 1 plus 0. So it's not C. And the next would be negative 4 minus 4. That's not 0. But if we look at this one, the determinant of this matrix would be 4 minus 4, which equals 0, which means it's not invertible, which means it is the answer, E. For number 56, 9 horses, lettered A through I, are entered in a race. What's the probability that the top 3 finishers, win, place, show, in the race would finish in consecutive order? Well, let's check it out. So we could have A, B, C in first, second, or third. We could have B, C, D. We could have C, D, E. Or D, E, F. Or E, F, G. Or GHI. And we've got 1, 2, 3, 4, 5, 6 different ways that they could do it. Well, the probability for each of these is going to be 1 out of 9 times 1 out of 8 times 1 out of 7, because there's 9 letters, and there's only one way that you could come in A, then B, then C. As soon as A crosses, there's 8 left. As soon as B crosses, there's 7 left. And we just saw that there's 6 ways to do this. And so our probability then should be 6 times this. Oh, pardon me, wait a second. 1, 2, 3, E, F, G, G, H, I. Did I miss one here? A, B, C, D, E. Oh, I forgot F, G, H. Sorry about that. F, G, H. F, G, H. And so if I look at that, then I should have 7 times this, which would be 1 out of 72. So there's a 1 out of every 72 races. There's a 1 chance that H, G, no, J, K. So J would be our answer. For number 57, find all possible values of B such that the distance between 3 plus bi and 1 plus 3i on the complex plane is the square root of 29. So what I want then is the square root of 29 to equal the square root of 3 minus 1 squared plus b minus 3 squared. Now, how did I get that? You're probably wondering. Well, I'm going to show you right now. If I consider the complex plane, where this is the coefficient of the imaginary part, and this is the coefficient of the real part of any complex number. And if b is positive or negative, well, I'm going to go to 3, and I'm either going to be b here or I'm going to be b here. And so this could be the point 3 plus bi if b is positive, and this would be 3 plus bi if b was negative. And then 1 plus 3i, well, I go out 1 and I go up 3. I don't know where b is. I'll just say 3 is right there. So I'm either going to be this distance or I'm going to be this distance. Well, I can use the Pythagorean theorem now to show that. So I just take the difference of the x's and the difference of the i's coefficient in this case. So this becomes 4 plus b minus 3 squared. Is going to be square root of 29. Well, then I can use that idea to say that 29 is going to equal 4 plus b minus 3 squared. Pardon me. So 25 must equal b minus 3 squared. Which means that b minus 3 must equal plus or minus 5. Which tells me that b must equal 3 plus or minus 5. Which would be either 8 or negative 2. So E is our answer in this particular case. Whoops. For number 58, what is the maximum value of the function f of t equals this big ugly thing? Well, we note something right away. This is an absolute value, 1 minus an absolute value. So whatever comes out of here is going to be greater than or equal to 0. So the least that this term could be, the k minus 1 over a cubed root of whatever, they could have put 100 different things inside there. The biggest it's going to be, we don't care, but the smallest that it's going to be is going to maximize f of t. And so we want this to be 0, which means that the biggest that f of t could be would be g. Tricky little problem. For number 59, we're asked which of the following data sets has the greatest range. Well, the range is the largest number minus the least number. And so if we look at that, negative 105 minus negative 1010 gives us a range of 5 for the first one. If we look at the second, the range here would be 5 minus negative 5, which is 10. So B is looking good right now. The range here would be 5 minus 0. The range here would be 15 minus 10. The range here would be 25 minus 20. And so B was the largest spread between the highest and the lowest, which is the definition of range. And so the largest range would be B. Last one, number 60. The circle with equation x plus 1 squared plus y minus 1 squared equals 1 is graphed on the standard xy coordinate plane below. Now suppose the circumference is a string that's unraveled. And we're going to take it along the x-axis. We're going to undo the string. And then we're going to stretch it out as far as we can this way. And what we'd like to find is the x-coordinate where the string ends. Well, we can see that the radius of the string is 1. We can see from the equation that it's centered at negative 1, 1. So with a radius of 1, then the circumference of the string, or length of the string, should be the circumference of the circle, which is 2 pi. This first part right here is going to be 1 unit long. So the part that goes up here is going to be 2 pi minus 1 unit. Now, note that this triangle right here is an isosceles right triangle with a hypotenuse of 2 pi minus 1. So this distance here, the leg, which would be x, must be 2 pi minus 1 over root 2, because it's a special right triangle. But I don't see that answer. So I must have had to rationalize the denominator. So I multiply this by root 2 over root 2. Again, multiplying by 1 doesn't change the value. It gives us an equivalent view of what this function would look like, or this value would look like, pardon me. And I get 2 root 2 times pi minus root 2 over now a rational, or pardon me, integer value, which makes it a rational number. We've rationalized it. And we can see that G is the correct answer. I hope you've been successful in this test. And I hope you're getting better. And I hope you feel that way too. Trust me, it's not a quick process, but it is a process that works. I've been through this many times with students. I've been through many students that have been through this. And the amazing thing is that more students that I've worked with over the last 10 years have scored perfects on the SAT and ACT math sections, just by maintaining a continual practice with good material and asking the right questions. Good luck on the next test.